All right, time to start trigonometry, my favorite thing to teach in math because it's cool. So, there are things in math that you have to memorize, and there aren't many of them. Whenever you can ask a question about why something is true and get a real answer, then you're not really basing your thought on memory, you're basing your thought on understanding. And that's what we want as much as possible. One example is PEMDAS, right? The order of operations. There's no real reason why it has to be that way. It's a matter of convention. We agree to do it that way in the same way we agree to capitalize the first word of a sentence. So PEMDAS is something for which there's no real explanation other than convention, and so it's something we just have to know as a matter of memory. Today's lesson involves one of those same things, and it's the definitions of the trig functions. So trig is about, to me, triangles, and it's about right triangles. So let's say I have this right triangle, and I have this angle right here, which I will call theta. And that angle, you could see, like, if I kept this side constant and that side constant, if I made that angle bigger, then this side would grow. If I made that angle smaller, then this side would shrink. And the thing about trig is a part of math where what we're looking at is that the ratios of the sides of the triangles depends on how big that angle is. So, and if I made the triangle smaller, let's say I had, instead of this triangle, I had this triangle, the ratios would be the same. Because that black triangle and that blue triangle, because they share angle theta, and they both have a right angle, they are similar by angle-angle similarity. And as a result, all the sides will be in proportion. Proportions are where ratios are equal. So the ratios that go with that green angle theta are going to be the same no matter how big the triangle is. So we can name that ratio, those ratios. We can say that the sine of angle theta, and so the definition of what the sine of angle theta is it's the ratio of the opposite side over the hypotenuse, which is the opposite side. Well, let's say that this is 3 and this is 4 and this is 5. The side opposite would be 3, right? So opposite is 3 and the hypotenuse is 5. So the sine of that angle would be 3/5. That's the ratio of those sides. There's also cosine. Cosine is the adjacent side compared to the hypotenuse. And the adjacent side, well, it's not the opposite and it's not the hypotenuse, it's the other one. And adjacent means next to, right? So this angle has 4 next to it. It also has 5 next to it, but 5 is the hypotenuse. So the adjacent side is 4, the hypotenuse is 5. So the cosine of that angle is 4/5. And there's tangent. The tangent of an angle is the opposite side over the adjacent side. So opposite side is 3, adjacent side is 4, the tangent of that angle is 3/4. So that's what SOHCAHTOA is. It's a way to remember. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. These are the big three of the trig functions. Now these trig functions come with like ugly cousins. And the ugly cousins are actually the reciprocals. And we don't use them as much. We could, but we don't use them as much. So for example, the reciprocal of sine is called cosecant. So the cosecant of the angle is not opposite over hypotenuse, but it's hypotenuse over opposite. So it would be 5/3. The reciprocal of cosine is called secant. The secant of that angle, instead of being adjacent over hypotenuse, is hypotenuse over adjacent. So hypotenuse over adjacent, That's 5 over 40. Tangent of an angle is opposite over adjacent. The cotangent of that angle is the reciprocal of the tangent. So that would be the adjacent over the opposite, and that would be, if this is 3/4, that would be 4/3. So there's 6 trig functions altogether. These are the definitions of those trig functions, and this is just something you have to know. How do we use these? Well, we can use these in a couple ways. I mean, one thing that we need to know is we need to understand that this is a function. So if this is a function, right, then it will have inputs and outputs. So let's say I take the sine of an angle. Well, the input to this function is the angle. And what it gives me out is the ratio that goes with that angle. And so the ratio depends on the angle. And so we put an angle into sine, so we do the sine of 20 degrees, for example. And that points to a certain triangle that has certain ratios of the sides. Well, if that's the function, then we certainly could have an inverse function. You may remember that an inverse function undoes what a function does. And it's where the inputs and the outputs switch. So you will notice, maybe you'll notice, hopefully you'll notice, on your nerdulator, like here, okay, so here, there's buttons sine, cosine, and tangent, and above it is sine -1, cosine -1, tangent -1. So what that is, that's not a reciprocal. What that is that is an inverse function, the same way that f of -1 of x is an inverse function. So if I have an input here, it will be the ratio. This is for sine -1 of theta. And the output will be an angle. So we can use this to get angles. So for example, if I go back to here, and I wanted to figure out what angle theta is as a degree measure, I can do that with my nerdulator. So the sine is 3/5, for example. I can go to my calculator, and I can put in sine -1 of 3/5, and it will give me, hey, that's a 36.9 degree angle. So this is a 36.9 degree angle. Alright, so inputs, outputs, it's the same as what we've been studying. You can also use trig to find sides of triangles. So like, let's say that you know you've got this triangle, this poorly drawn triangle, and you know that this is 40 degrees, and you know the hypotenuse is 10. And you want to find what the other sides of the triangle are. Well, let's say you wanted to find how tall this triangle is, that other side. That's the opposite side. So you have the opposite side. You want the opposite side. You have the hypotenuse. So opposite and hypotenuse, that's the sine. So the sine of 40 degrees will equal the opposite side over the hypotenuse of this triangle. So that means the sine of 40 degrees would equal, I don't know, let's call this h for height, h over 10. Well, that means that I could take this equation, I could multiply both sides by 10, and the height would equal 10 times the sine of 40 degrees. And you can just take that, you can put that in your nerdulator. I'm going to do that actually. So let's see here, 10 times the sine of 40. Bam. 6.42. So if I go back here, I know that this should be 6.42 inches or whatever. You know, if you get that answer and let's say you got 16.42, you would know you were wrong because the hypotenuse is always the longest side on a right triangle. So you can kind of test your answers to see if they're reasonable. One last thing, and that is making nice with your calculator. Your calculator, so trig can be done in degrees or can be done in radians, and the difference really comes down to whether you want to focus on circles or focus on triangles. So for now, we're going to focus on triangles, and so you want to make sure your calculator is set on degrees, otherwise all your answers will be wrong. And the way to do that is you go to the mode button, and you get a list of stuff, and on the third line it says, you know, radian or degree, and make sure it says degree. Yeah, that's it. Lesson over. Next stop is to take the triangle and rotate it around a circle and see what happens. We'll do that tomorrow. All right, bye.